In this video, we are going to look at solving linear inequalities. Now, you may remember an earlier video where we talked about solving inequalities with one variable and we had something like a number line. Well, here we're going to be doing this with two variables. We're going to have an x and a y, and we have to figure out how can we graph those on a coordinate plane like we see in front of us. So I'm not going to waste any time. Let's get right into it. Here we see an inequality, y is less than 3x plus 4. For the most part, when we graph this, it looks like it's in slope-intercept form, and we are going to graph it as if it was slope-intercept form. But the main difference is going to come in with the inequality symbol. The inequality symbols tell us what type of line we are going to use. So if I have a less than or a greater than, this means our line, which I'll draw in green, is going to be dashed. It is not a solid line. And if we have an inequality that is less than or equal to, or we have an inequality that is greater than or equal to, this means we are going to have a solid line between all of our points. That is very important to remember. So if it's less than or greater than with no line underneath, you are going to have a series of dashes creating your line. But if it's less than or equal to or greater than or equal to with the line underneath, you are going to have a solid line. Now I'll leave these up just to help us remember, but let's take a look at our inequality here. We start with the y-intercept, the point on the y-axis that the line passes through, and it is positive 4. So I'll put a dot at positive 4 right here. Then we take a look at our slope. The slope is 3, or 3 over 1. And if we remember how to graph our lines, the slope tells us rise over run. And since it's 3, or 3 over 1, we go up 3, right 1. So I will have another dot right there. Now, if I want to have more dots, I could do the opposite. I went up and to the right. So the opposite would mean I'd go down 3 and to the left. So that is what I can do. Down 3 and to the left, do it again, down 3 and 1 to the left, down 3 and 1 to the left, and so forth and so on. So there are my series of dots that I will connect. But remember, we have to remember, do we have a less than or greater than, or do we have a less than or equal to or a greater than or equal to? In this case, we have less than, so I'm going to have a dashed line. So I'll just make little dashes between my dots. It doesn't look the greatest because I'm not using a straight edge, but there we go. So we have our line now. But we're not done. With graphing inequalities, we have to remember, all right, what does this say? Y is less than 5. What this says is that y is smaller than 5. As long as it's smaller than 5, well, it's going to satisfy this inequality. I could have 2 is less than 5. That's true. I could have negative 7 is less than 5. That is also true. I have an infinitely many solutions here. And when we graphed this on a number line, we showed that with an arrow going to the left, and this was 5, and so forth and so on. So how can we show it in this? How can we show all the solutions? Because the line is not the solution. The line is actually like a boundary that your solutions will be on one side of, and your non-solutions will be on the other side. Now, there's a couple different ways that you could check this or figure out what side of the line, either over here or over here, work. My suggestion is to check the origin. This is 0, 0. That is your origin. And what I mean by that is I'm going to take these points here and I'm going to plug them into my y and my x up here. If it gives me a true inequality, I'll know that I need to shade this side. If it gives me a false inequality, I'll have to shade the other side because this point was not a solution. So let's check it out. If x and y are both 0, that gives me 0 is less than 3 times 0 plus 4. Simplifying that down, I get 0 is less than 4. And I have to ask myself, is this true? Is 0 smaller than 4? And hopefully you say, yes, 0 is smaller than 4. So I will now shade, and I'll do a very quick job, this side of my graph, because all of my solutions are over here. I didn't have to just prove 0, 0. I could use any point on this side of the line, and it would satisfy our inequality. And just to prove that, let's prove one that doesn't work. Let's take this point right here, which is -3, 3. So if I plug those in, 3 is less than 3 times -3 plus 4. That's going to give me 3 is less than -9 plus 4. 3 is less than -5. And hopefully you can see here 3 is not smaller than -5. This is a false statement. So I know this side does not satisfy the inequality. Only this side does. All right. Did you get all that? It's a lot to take in at first, so why don't we try another example, maybe 2 more, and get some practice with these. But once we get them down and are graphing with our solids or our dashed lines, it works out pretty nicely and is not too terrible. So let's take a look at example 2. All right, here we have our second example. 3x plus 2y is greater than or equal to 6. And this time we do not have slope-intercept form. We have standard form. We have our x's and y's on the same side. So graphing this is a little bit different. We could change it into slope-intercept form, but in this case it actually would be simpler to leave it like this. To get our graph, to graph our line, I need to get my x and my y intercepts. So really what I do is, if I want the x-intercept, I'm going to pretend that 2y isn't there. And to get my y-intercept, I'm going to pretend that 3x isn't there. So if I pretend it's just 3y is greater than or equal to 6, divide 6 by 3, and we get 2. So my x-intercept is at 2, because 3 times 2 gets me 6. Now if I want my y-intercept on the y-axis, I'm going to pretend the 3y is not there, and I have 2y equals 6. So if I divide 6 by 2, I get 3, and 3 is my y-axis intercept, because 2 times 3 here gives me 6. And now I have my 2 points, which is really all I need in order to create a line. I just need 2 points, and then I can use my ruler. Since I don't have a ruler, I can actually get a couple more points by seeing, hey, from this point, I have to go down 3 and over 2 to get to my next point. So I could do that again, go down 3 and over 2 to get a point there, down 3 over 2 to get a point there. And then if I want to go up this direction, I can go up 3, left 2, and that will give me my last point that I can actually fit in here. So we have our points, we can create our line. We just need to decide, do we need a dashed line or a solid line? So look at our inequality up here and decide, do we need a dashed or a solid? Hopefully you said a solid line because we have greater than or equal to. That is over here. That is the solid line. So using our ruler, if we have one, we will connect all of our dots the best we can. And now, just like in the last example, I can either shade below the line or above the line. And what will tell us how to do that is the origin, 0, 0. If the origin gives us a true statement here, we know we will shade below the line. If it gives us a false statement, we know we will shade above the line. So let's go along with plugging in 0 for x and y. 3 times 0 plus 2 times 0 is greater than or equal to 6. This turns out to be 0 is greater than or equal to 6. And ask yourself, is this true? Is 0 bigger than 6 or equal to 6? And hopefully you say, no, it is not. So since the origin failed and gave us a false answer, or a false statement, I know I'm not going to shade where the origin is. I need to I need to shade on the opposite side. So we will shade in the top of our coordinate plane, and all of our solutions will be up here. We're going to do one more example, and we're going to see what we can do if we can't use the origin, because sometimes when we graph, the origin is not going to be the point that we can actually check. So we'll figure out what to do there. So meet me over at example 3. For our final example here, we have y is less than 2x. Now, I do not have a y-intercept, so really this is the same as plus 0 for our graphing purposes. So our y-intercept is at the origin. It is right there. Now we need to graph our line using our slope. The slope is 2, or 2 over 1, meaning from my intercept, I'm going to go over 2 and up 1 to right here. There's my first point, and then I will continue doing so, up 2, right 1, up 2, right 1, until I can't anymore. Then, if I don't have a ruler, I can go the opposite directions, down 2, left 1, and continue the line in the opposite direction. So there are our possible dots. What do we have to do next? Think to yourself, what's our next move? Hopefully you said decide if our line is dotted or solid. So take a look at our inequality. Does this call for a dotted line or a solid line? And I guess I used dashed line before. Dotted, dashed, same idea. We need a dashed line here because it is just less than, not less than or equal to. So our dashes will come in. Excuse me. And now we have our dashed line. We need to decide, are we going above or below the line? But our point is already taken. Normally we use the origin, but the origin is right here, and it's on our dashed line. The fact that it's on the line tells us we can't use it. So what do? Every example we've done so far, we've used that origin point. And the answer is choose a random point somewhere else that is not on the line. I've got all these points over here. I've got all these points over here. Any of them are fine to use. I could use this point right here, which is -3, 3. I could use this point down here, which looks like it is 7, -7. I could use any point as long as it's not on our line. If it's true, if it gives us a true statement, we know that we shade that side. If it gives us a false statement, we shade the opposite side. So, you know what? Let's go with 7, comma, -7. If I plug those in, -7 is my y, so -7 is less than 2 times 7. That gives me -7 is less than 14. And is that a true statement? Hopefully you're saying yes. -7 is less than 14, so I will shade in the side that has 7, comma, -7. Now, just to double check, in case you don't believe me, let's throw in -3, comma, 3 to here as well. So if I have 3 is less than 2 times -3, I get 3 is less than -6, and hopefully we realize this is a false statement. 3 is not less than -6. So, since this is a false statement, I would not shade the side with -3, comma, 3. Instead, I would shade the opposite side of the line, which we've already done. And there you have it. We have successfully solved linear inequalities using graphs. Hopefully you found this video useful, and good luck.